Hello everyone, thanks for joining us and welcome to Build Architecture 2021. My name's David Weir-McCall, AEC Business Development Manager at Epic Games.
And my name is Belinda Erkan, Product Marketing Manager for Twinmotion. We'll be your hosts for today's event, and in the next 90 minutes we'll explore exciting customer stories and we'll learn how real-time technology is changing the world of architecture.
Right, and that's why we've gathered these amazing customer stories from across the globe, which will be just a glimpse at what is possible. But if you want to learn how to do it for yourself, after the event we'll share details and resources in our post-event messaging at unrealengine.com.
Right, so we are going to present our stories with the help of the virtual production technology currently changing the face of Hollywood. If you've seen the popular Mandalorian series, you have seen Unreal Engine in action, creating virtual worlds in real time. So David and I are here in a Montreal soundstage, and we've created a virtual studio setting custom-made just for this event. So this will be the stage, and we'll be covering 3 acts. Act number 1 will be all about storytelling with Twinmotion. We'll go over to Act 2, which goes beyond with Unreal Engine, and in the final act, we'll be building the future with digital twins and open worlds.
At the end of the 90 minutes, join us in one of our dev lounges for some real-time Q&A with many of the people involved in today's presentations. We're going to kick things off with our General Manager of Unreal Engine, Mark Petit, but please stick around for the entire event as we'll be sprinkling little announcements in each of the acts that you will not want to miss. So buckle up, your trip to the future starts now.
Hello everybody, my name is Mark Petit and I'm the General Manager for the Unreal Engine at Epic Games. As you know, Epic Games is assembling a portfolio of solutions for content creators across all media with a particular focus on the needs of the AEC industry and visualization. You're familiar with the Unreal Engine, but we also have our Twinmotion product, which is for you the simplest way to harness the power of the Unreal Engine. And we also more recently brought into the family the reality capture team, which is the best solution out there in terms of photogrammetry and giving you this ability using drones or LiDAR scanning or photography to actually capture the existing 3D world, the as-built, and bring it into the virtual world with your design. The reason why you're hearing so much about game engine, the AEC industry, and particularly the Unreal Engine, is because it brings photorealism to the real-time domain. You've seen this with the UE5 demos. UE5 is going to make it even much further in terms of visual fidelity. And so the promise of that photorealism in real time is important. Real-time 3D is kind of a revolution in content creation for 2 reasons. Reason number 1, it's the most efficient way, cost-efficient and time-efficient way of creating your visualizations, creating those pictures and those video to represent your designs or to sell your design. The other important aspect about real-time 3D, that is enable digital twin. You're familiar with the concept and believe digital twins are very important for owner-operators to make sure they understand how their assets are performing. And today you will hear a number of presentations about digital twin and how the Unreal Engine actually allows you to get to the digital twin in a very easy manner. As you know, architecture is all about spaces, so the ability to explore a design in VR is critically important. We bring that to the table, especially with the level of visual fidelity that we achieve now, or just letting people interact with the space, guided tours, or even use the interactivity, to do those configurators that we've seen. And finally, more recently, we announced Sketchfab joining Epic Games. Sketchfab is important for us because this is how you publish your content on the web, how you publish your 3D model on the web, just like you would do by putting a video on YouTube. Now you can take your 3D models and put them on Sketchfab to make them available to everybody on the internet. So we think that real-time 3D is transforming the way you create your visualization and your content, and also real-time 3D is powering your digital twin. As the internet embraces more real-time 3D, we'll see the creation of more ambitious projects around those shared virtual spaces often referred to as the metaverse. We don't quite know what the metaverse is going to be, but we think that the right way to get ready for it is to embrace real-time 3D, embrace the Unreal Engine, and start bringing your design into it. So thank you. Today we have a great lineup of speakers for this event. I hope you enjoy the content and hearing from your peers. Thank you very much, and we'll see you in the chat.
Thanks, Mark, for sharing how real-time technology enables content creation for creators, moving us all to the future metaverse.
All right, so in this first act, Storytelling with Twinmotion, we are introducing a range of customers from freelancers up to large firms that use Twinmotion for visual storytelling. And believe it or not, we have plenty of those storytellers because over 1 million people have already registered for Twinmotion over the last couple of years, which explains why Twinmotion is the second most popular real-time tool used by people who care about their pixels.
What's the most popular one? Well, according to 2020 CG Architecture Survey, it's the Unreal Engine. And today we're going to help you understand why there's all this momentum towards our real-time solutions.
Right. Now, we know many of you are designers and creators, and you just want your visualization tool to be kind of like that extension to your creative mind. But such an extension needs to be very simple and fast and quick and rich in assets and collaborative. And let's not forget all of this with the highest visual quality right out of the box. Sounds crazy, I know, sounds unimaginable, but you really don't need to imagine this any longer because Sam Anderson has something very interesting to share with you.
Thank you very much. I'm Sam. And as many of you may know, the next Twinmotion preview has just been released. I'm here to take you through a few key features. Here, you see Twinmotion's newest photorealistic rendering technology. The new release leverages the power of Unreal Engine. You'll be able to render your 3D scenes with path trace technology right inside of your viewport. It's going to take advantage of all of the GPU hardware to give you a very accurate, high-level visual quality of shadows, lighting, and reflections. So if you're used to working with the workflows as you are right now, that's totally fine. You can do that so that you have quick prototyping and immediate results. And then for later design stages, you can quickly switch to path tracer mode if you need to add that extra level of photorealism to your story. To further refine your story, we've added nearly 300 sky domes into our Twinmotion library. These are going to give your models that extra touch of realistic lighting quality. You can browse through a variety of skies or even upload your own custom HDRI. Now, if you would like to, you can combine the technology of Path Tracer with the HDRIs so you can leverage the information in the sky texture so you can get the correct reflections in the background and in your glass, making your story that much more immersive. Now, in addition to the sky domes, we've added other assets into our Twinmotion library, including 3D plants, decals, and furniture, all optimized for real-time performance. Currently, we have 10,000 assets inside our Twinmotion library. We'll be able to add in Twinmotion assets as they are developed. Now, this will be regardless of the Twinmotion release, so that you can bring in your assets at any time. Many design firms work with design components in different softwares. So for example, you might have structural data in one program and your landscape data in another. For us, it's very important that Twinmotion helps your data stay more interconnected and streamlined. We've been continuously improving our Datasmith plugin technology, which now enables you to link multiple files of various CAD data into one single Twinmotion scene. You'll be able to reload updated geometry, develop the models in one environment, and even take your project into Unreal Engine if you need that next level of customization. The Datasmith plugin opens up a degree of interoperability that was not present before. Now, the creative design process isn't all about designing and visualizing. It's also about collaboration and communication. With our Twinmotion Cloud, you'll be able to share your design presentations to anyone, regardless of software, hardware, or location. Anyone with an invite link can access your presentations through their browser on both desktop and tablet devices. Last but not least, we added a new content type, panorama sets, which allow you to curate lightweight, high visual 360 images. So with the next release of Twinmotion, you'll have a true design companion tool. It will be simple, rich, powerful, and connected. Be on the lookout for an offer from us to download it for free.
Thanks, Sam. You see that one simple, quick, fast, collaborative extension of your creative mind is becoming real with the next version of Twinmotion. I'm sure you'll be keeping your GPU busy with the path tracer right out of the box. Also, there's a lot in the release beyond what Sam had time to show you, so make sure you try it out for yourself and please share your work with us. I'm looking forward to your stories. Now, speaking of stories, the next one is about how Twinmotion actually changed someone's life. I'd like to introduce Paweł Rymża.
Hi, my name is Paweł Rymża. I come from Poland and I was software analyst for 5 years. And at the time I was also finishing my first apartment, and I thought it would be really cool to be able to show it to my family before it's built. That's the time when I found about Twinmotion, and I quickly downloaded it and started to work in it. And after a few days I was able to showcase a quick walkthrough video to my family. They were really impressed by the quality, and in the end that's exactly how my apartment looks. So I was able to make the final version of it inside Twinmotion. I found out about Twinmotion challenge which was taking place. It was a short animation of modern building in fall, and actually I was able to win it. After a short while I found about another Twinmotion challenge, and I had to create a green space in urban jungle, and I created image which actually won again, and that gave me additional boost of confidence to think about it maybe not as a hobby but something which I could do for a living. So I decided to create my own company. I was finally able to self-sustain myself from my work, which was a great feat, and that gave me a lot of boost of confidence to just keep working and keep getting better. The reason why I started using Twinmotion was because it was super easy to use. It was really quick. I had no architecture background, yet I was able to create my apartment in few days. I'm still surprised by how quickly I'm able to create a vast landscape with trees, grass, people walking, cars driving. Few clicks and you have everything set up for the render. For 99% of people, the things which you can do in Twinmotion in minutes are more than enough to present to the client. The current version of Twinmotion introduces one of the biggest improvements so far, which is path tracing. It's actually a way to make your scenes absolutely photorealistic, especially visible in interiors where light bounces through different objects, and thus creating those soft shadows which are now present inside Twinmotion. Other than that, there is also HDRI skies, which allows you with one click to change whole scene from day to night and give you also a correct light representation inside your room or inside your apartment. Thank you very much for being able to tell my story. I really encourage everyone to start using Twinmotion. It's really easy and fast, and hopefully you will have as great of success in using it as I did. Have a great day and thank you very much.
Thanks, Paweł. It is indeed an incredible, life-changing story and certainly an inspirational one. So if you want to see more of Paweł's inspiring work, head over to our official Twinmotion community group on Facebook. Now, speaking of the community, we also wanted our talented Twinmotion users to share their passion with you. So we'll have them show their artistic work in this short compilation.
There are three things that I love about Twinmotion. First, It's very intuitive. As a PC gamer, I don't have any trouble navigating around the scenes and getting used to the user interface.
For me, it's all about images and animations, preferably as realistic as possible. It's ease of use. Whenever you like a texture but you don't like its color, with one slider you can change your entire scene.
What we love the most about Twinmotion in our studio is the perfect integration in the pipeline with Architect plugin that allow us to import very fast our project in Twinmotion and to make some changes very easily.
Making Twinmotion visualizations interactive through the Twinmotion to Unreal Engine bridge, as well as through cloud sharing experiences.
Second, the rendering time is very short compared to other programs.
It's easy when a client is with you at the office. You can just change some simple lighting and your scene will look completely different without having to wait. The cloud is also a good option. This way the end user can easily walk around in his design without having to download anything.
Yeah, you dive into your project and you get the results on real time. That's perfect, and you get what you see.
The updates and latest integration of the Quixel Megascan library make it the perfect tool for me today. A real pleasure to work.
The VR experience is great, especially if you want to share your project with others. That is the reason that I started to use Twinmotion. And when I'm working with Twinmotion, my mind escapes from the domain of the daily architecture, and I see possibilities of creating new forms of art.
Third, it's very easy to teach the program to my colleagues and integrate it into our design workflow at the firm.
It's just really fun to use since everything is real time, the response is real time. Really enjoy the exploration of design options. It just feels effortless.
It's not just about the program, but also about the social aspect when people come together and share their knowledge. To me, it's been a very fun journey so far.
The Twinmotion user community is super friendly and very stimulating and never lacks imagination. I learned so much with them. Thank you, Twinmotion teams.
I think what I like most about Twinmotion is the creative freedom it provides me to express my ideas, my work, in what I find to be the simplest way possible.
So have fun and never stop creating. Bye!
What a great community. Amazing to see the different ways that people are using Twinmotion.
And speaking of community, we are often asked, where can I find someone with real-time skills? Well, recently, ArtStation joined the Epic Games family, which is a leading global platform for discovering and showcasing art and connecting creators with opportunities. So if you're a creator, ArtStation is a one-stop shop with all the tools needed to showcase your artwork, improve your skills, and develop your career.
That's right, and it really was designed with artists in mind. You can share your 4K images, videos, 360 panoramics, or even full 3D models. It's also a great place to earn passive income selling digital or printed assets, or even learn something new through ArtStation Learning. And for anyone looking to hire a creator, ArtStation is an excellent free tool to easily search and browse artist portfolios from a range of different industries.
And now our next story is about transformation and comes from Ernesto Pacheco from Canon Design, which is a large architectural firm based in New York. And they will show you how they used real-time to transform their process with Mercy Hospital.
Hello, my name is Ernesto Pacheco. I am the Director of Visualization at Canon Design. We are a global design firm with over 20 offices throughout North America, Asia. My main role at Canon Design is research and development of digital technologies into our design practice. We have been using Unreal Engine since 2015. We introduced this tool as a more interesting ways to tell the story. The only thing that you have to take into consideration with Unreal Engine is that it's a very sophisticated tool. It takes a little bit longer to get used to, and also training takes a little bit longer. So when Twinmotion came to light, we were very excited. We saw Twinmotion as this one-step solution for designers. We wanted to expedite especially animation processes and have smaller teams working on tasks throughout the firm. One of our talented designers from our St. Louis office, Alison Mendez, had an animation project that she needed to complete for a client. This project included over 300,000 square feet. And for this particular project, we had interior, exterior shots. We also had a lot of landscaping elements moving. We actually partnered with a landscaping architect. So we were able to share the Twinmotion library with them and have them optimize landscaping elements that we could use and iterate throughout the space. We are always fascinated with how easy it is to iterate with Twinmotion. One of the challenges that we actually faced is how we share these type of solutions with clients. We used to, export an executable, share that via a cloud service, and then the client will have to have access to a gaming laptop to actually open these files. And so when Twinmotion offered the cloud service, we jumped right into it. So having access to this cloud service allows designers to just send a link, then the client can just open that on a laptop or a mobile device, for instance. They don't have to have a dedicated hardware that runs, a high GPU. One of the things that we love about Twinmotion is how easy it is to just open the file and jump on a virtual call with the client or the design team and have these organic conversations happen. We can, move things around, change materials, add assets, and everything happens in real time. You really don't have to wait for anything to pre-render. It creates this organic interaction with them, and the whole experience, becomes more natural. It's a testament to how easy it is to pick up Twinmotion for any type of work, any type of visualization work in this case. And we were happy with the outcome. To have Ricardo Orfilia from our Baltimore office to take on this project. This was actually his second animation project ever. So I was very impressed to how easy it was for him to pick it up and actually lead an animation project all by himself. So in a nutshell, Twinmotion is super easy to use. It's amazing when somebody opens Twinmotion and starts playing with it. You can see their smile in their faces. It's super fun to use. You have access to a real-time solution. That means that you can have real-time reviews with clients, which is priceless. It's something that now we do on a daily basis. So thank you again for the opportunity at Unreal Build 2021, and I hope to see you soon.
Thanks for sharing that story, Ernesto. The Twinmotion Cloud Service is really helping firms connect and collaborate with their customers. And with the new panorama feature that we're launching for Twinmotion Cloud, we're excited to see what you can do. So next, let's go big. And by big, I mean Jens Karslom and Václav Sporenko from Blake Ingalls Group, otherwise referred to as BIG. See what I did there? They're headquartered in Copenhagen and known for their innovative design approach. And they're here to talk to you about how Twinmotion is helping them tell their stories.
I'm Jens Karslom, BIM Director here at BIG in Copenhagen, Blake Ingalls Group. Normally I'm looking after our BIM operations, but I've been an early adopter and a long-time advocate for real-time rendering, and also one of the ones pushing a lot for real-time rendering internally here at BIG. And what we particularly like about Twinmotion in this case is the animated part and being able to really sort of tell a story. That's where we find Twinmotion being the one to go for. The project we want to showcase today is our AI city for the Terminus Group in Chongqing in China, which will be the new headquarter for the Terminus Group, and also this sort of innovation hub, which will be super exciting. It's a project that we worked on for quite a while, and obviously, as you can imagine, we are doing a lot of different options with all our projects here at BIG. So it's obviously a fantastic way to be able to utilize real-time rendering, to be able to sort of walk the project even in the early stages, and it provides us a better way to hone in on what option we want to go for, and to sort of push the amount of options that we go with further into the project, where we would normally have to narrow down way earlier. In this case, we can keep more options in play. And I think that's where real-time rendering has its big positives, that you can really explore and utilize different options and play around with things and still get a really good result out in a very short time frame.
Hi, my name is Vladislav. I am visual designer at Blake Ingalls Group here in Copenhagen office. Since the core idea of the design was to remove the barrier between architecture and nature, and also show how the robotics and artificial intelligence would look like in the future, we needed to emphasize those ideas, and Twinmotion and real-time in general helped us to find the good solutions during the design process and also in the final video production. We're using the real-time engine not only for the final production of digital media, but also during the early design stages, such as searching for the ideas or seeing how the space will interact with the people. And the real-time engine allows us to actually be as a human inside the project and see how it would work. We learned that Twinmotion has a lot of really handy tools that allowed us to reduce the production time in general and meet deadlines in time, such as the huge material library and the 3D models that allowed us also to use and experience different scenarios that we wanted to present to the client and approve different architectural ideas. If I can compare the real-time engine to the traditional ways of digital production, I can say that the artists can feel the pure freedom in terms of what they create, such as the moody images or animation production, because the software allows you, having not knowledge of the technical aspects, still be able to produce nice images and animations.
Thanks for watching. I hope you enjoyed what we showed you here today and enjoy the rest of the event. Thanks for having us.
Thanks Jens, thanks Vladislav. Looking forward to seeing more. According to Architectural Record, HOK is the 5th largest architectural firm in the US. And as today's event is a journey, we're going to see HOK appear in each of our 3 acts to show how epic products are being used across a firm in different ways. We're going to start by bringing on Greg Schleusner and Caitlin Lagis to talk about how they're using Twinmotion for interactive design reviews on a rather important building.
Hi. My name is Greg Schleusner. I'm the Director of Design Technology for HOK. HOK is a global architecture, engineering, and planning firm. I'm going to talk to you today about the Center Block project, which is Canada's Parliament. The Center Block project is a full seismic, architectural, interior, electrical, and mechanical, and heritage upgrade to the building. During this time, the Parliament has actually left the building for the duration of the project, which is at least 10 years. Fundamentally, the complexity of this project is added to the fact that it's an ongoing construction site. We're continuously doing laser scanning, monitoring, and many other activities that help us understand the project. The ability to bring all this information together, the ability for us to execute on all these different areas of expertise is fundamentally why HOK and WSP were brought onto the project. Now let me introduce you to Katie, who will show you how we're using Twinmotion on the project.
Thanks, Greg. I'm Katie, and I work on the visualizations on the Center Block project. We use Twinmotion and Unreal Engine as a way to bring our clients with us on our journey through this project in real time through the different design phases and iterations. We take the scan data that we're getting from the exterior and interior of the building, and we process that through reality capture, and we get point clouds and high poly meshes. We take those high poly meshes through our procedural optimized workflow through Houdini, and that way we can get some LODs for use in Unreal Engine and Twinmotion. With this, we're able to create visualizations for our internal teams and our clients. An example of this is we were able to conduct multiple accessibility studies with our design teams. We were able to invite differently abled people into our live demos, and they were able to put on the VR headset, explore around, and actively tell us what worked and what needed revisiting. This helped the designers a lot to see their designs in real time and see, for example, maybe what's in reach, maybe wasn't in reach for someone with limited mobility. The flexibility to do this in real time saved us a lot of time and effort during the production process.
Thanks, Katie. We really like the way Twinmotion makes it easy to iterate early on in a project. What makes it unique, though, is the fact that we can transition that data into Unreal. This is something we'll show you later on in the presentation.
Thanks, Greg and Caitlin. As Greg mentioned, part of our vision is to allow Unreal Engine users to also benefit from Twinmotion's rich 3D content. And that's why in the last year, we've released all the Twinmotion content for free on the marketplace, and we've built a bridge to import Twinmotion projects directly into Unreal.
And with this bridge, you can start a project in Twinmotion and continue working on it in Unreal Engine. And we're also pleased to announce that we've been working with a team at Vectorworks to improve the Datasmith integration for Vectorworks 2022. The new workflow uses our direct link technology to dynamically sync changes while never losing the work you apply in Twinmotion or Unreal. This new workflow allows our tools to integrate more seamlessly into your workflows and lets you iterate more effectively and creatively.
That's right, and in addition, for a limited time, Vectorworks has announced that all current Vectorworks users will get a full license of the current release of Twinmotion for free. But not only Vectorworks users can benefit from our efforts to make Twinmotion accessible to as many people as possible. We are proud to announce yet another partnership, this time with the world's largest provider of PCs, Lenovo. Many of Lenovo's professional workstations, powered by NVIDIA RTX, will be eligible for a free copy of a commercial Twinmotion release. This is a great combination of both software and hardware.
And it's available for a limited time only. So stay tuned and we'll be sharing all the details after the event. So with that, let's take a short break. You can go stretch your legs, grab a cup of tea, and we'll join you on our next leg of the journey in Unreal Engine. Welcome back, everyone. Well, that was an action-packed first act with the announcement of the latest version of Twinmotion, with the Lenovo partnership and the new Vectorworks plugin. There's a lot of great things happening for you around Twinmotion. In Act 1, our customers showed the storytelling potential of Twinmotion. But what's great is that the journey doesn't end there.
Right, the journey continues, and in this next act going beyond with Unreal Engine, you'll see customers using the engine to go beyond the limits of traditional visualization and storytelling. And to kick this section off, we'd like to bring in our product managers Rod Recker and Pierre-Félix Breton to talk about how Unreal Engine 5 can take things to a whole new level.
Thank you, Belinda. Now, some of you may have heard of something called Unreal Engine 5. I'm going to tell you about just a few of the many new capabilities of Unreal Engine 5 that will help AEC users. Lumen is a game changer for interior lighting. Nanite allows for massive worlds with unprecedented object counts. And our new large world coordinate systems will allow you to create projects that can span the Earth. A lot of you have been using the Unreal Engine 5 early access build and have already seen how significant this release is. That's why one of the most exciting aspects of Unreal Engine 5 is that it takes real-time interactive visualization to a whole new level of quality. With it, you can easily bring in data from a number of sources, interact at higher levels of visual quality, and make stunning, physically accurate imagery all in one tool. In short, Unreal Engine 5 is making it possible for you to spend more time designing and less time managing your data and renderings. Datasmith is one of the elements of our toolset that makes it easy for you to bring your CAD data into Unreal Engine and Twinmotion. If you haven't looked at Datasmith recently, it now includes our direct link technology, which allows both Twinmotion and Unreal Engine users to create a live connection with their CAD tools and seamlessly sync their data. You no longer need to spend time manually exporting and importing data. Direct Link is available now for our Revit, ArchiCAD, SketchUp, and Rhino plugins and is coming soon for 3ds Max. Another important part of our Datasmith capability is the addition of an SDK that allows third parties like Vectorworks, Esri, and others to bring their data into Unreal Engine and Twinmotion. We now have over a dozen AEC tool vendors supporting Datasmith, and the list is growing rapidly. In fact, it's my pleasure to announce that Bentley Systems have recently developed an integration of their iTwin platform with Datasmith. Now you can extend 3D and 4D data from any Bentley solution powered by iTwin into Unreal Engine using Datasmith. In this video from one of our favorite partner studios, Solus, you can see an example where synchro construction sequencing data from a massive project in central London was exported from iTwin to Datasmith. The construction sequence and animation is pulled from Synchro and made accessible in Unreal Engine. This project, 100 Liverpool Street, is under construction by Sir Robert McAlpine, and the 4D planning work was produced by Freeform. Using these tools, you can now explore your biggest projects in unmatched fidelity and communicate with your stakeholders in ways never before possible. Unreal Engine was already known for the quality of its real-time visualization. That's why one of the most exciting aspects of Unreal Engine 5 is that it takes that quality to a new level. With Lumen as its rendering system, you can immediately see interactive global illumination results with little to no preparation or waiting for pre-processing. In most situations, you no longer need to wait for light baking or spend time performing UV unwrapping. You can get right to seeing your creation and speed up your design iterations. This real-time capability also makes it easier and faster to collaborate with your clients and stakeholders. The combination of Lumen with our physically accurate path tracer that was introduced in Unreal Engine 4.27 shows our commitment to making Unreal Engine a complete solution for all of your visualization tasks. You save time because you no longer need to move your design data between different visualization tools. You can stay in Unreal Engine and get both high-quality, real-time visuals and physically accurate stills and animations for marketing or simulation purposes. Now, Pierre-Félix Breton will tell us about some additional things that we're working on for Unreal Engine 5.
Thank you, Rod. First, I would like to thank the ArchViz community for demonstrating a strong interest in our technology. We're impressed by your work showcasing the capabilities of Unreal Engine 5. Myself and the team are watching social channels, and your feedback helps us building the right product. We look forward continuing the conversation with all of you. Now, as Rod mentioned, visualization artists and designers will be able to use Unreal Engine 5 to deliver beautiful results much faster than before. And there's another important aspect to the story. We are seeing more and more people use Unreal Engine for digital projects. You may be interested in creating an interactive dashboard to monitor the state of IoT devices installed on industrial equipment inside building or events happening at the scale of a city. To help you create digital twins of the physical world, I'm pleased to tell you that we're working on adding support for web-based remote control and IoT protocols as part of our standard feature set. For example, we're currently working on adding connections for MQTT, Node-RED, and OpenAPI. This will make it easier to start your digital twin projects in Unreal Engine. Later on, we will show great examples from our users showing digital twin capabilities done with Unreal Engine. But for now, let's have a look at even more great examples of Unreal being used for AEC projects.
Thank you, Rod and Pierre-Félix. Unreal Engine 5 and Datasmith will truly unlock a level of real-time exploration we have never seen before. And all of this moving us a step closer to an interactive version of our physical world. Now, to add on to this, we are working with companies all over the world to bridge their workflows with ours through Datasmith. And even though we already support many Autodesk products with Datasmith, we're not done. We are now working on a proof of concept to use Datasmith to link Autodesk Forge and BIM 360 platform with Twinmotion or Unreal Engine. We'll share more details about this early next year, and if you're interested in joining our beta, you'll find all the information on our post-event webpage at unrealengine.com. Now, I want to introduce Jose Uribe from PureBlink. PureBlink is a long-time Unreal Engine agency based in Toronto, and they're not only creating high-fidelity visuals, no. They're building entire interactive experiences to engage with the public around a very large development project.
Hello, my name is Jose Uribe. I'm the creative director and founder of PureBlink. We are a creative digital agency specialized in real estate visualization, interactive applications, and storytelling. Over a year ago, we were engaged by ILAD to help them visualize the third phase of Galleria on the Park. This is Galleria 3. It is part of a large master plan composed of 8 different buildings, an 8-acre park, a very large community facility with plenty of activities. One of the key challenges that we had with this particular project was the fact that it is located in a very industrial area. So for the typical prospect buyer, it would be very difficult to really understand and visualize and experience what this master plan community is going to be like probably 10 years from now once everything is built. Our approach was to not only create visuals or renderings of different areas of the project where we could visualize how the gallerias or the park were going to be like, but also an interactive application and a video component. And for all these different components, we used Unreal, and it was a critical technology to allow us to reach the level of photorealism and the level of cinematography in the video.
Preparing to launch a project during COVID had us quite concerned, and PureBlink provided the 360 solution that allowed us to bring clients through the community, whether they were in the sales center physically or at their homes. We believe that PureBlink's solution provided us the ability to hit our threshold, our sales threshold, within a shorter period of time during COVID.
Right now, we're extremely excited about Unreal and all the new features we've been testing heavily. Lumen, ray tracing, global illumination, path tracing, both on 4.27 and Unreal 5. It's absolutely amazing what you can do with it. Lighting is one of the most important components about it. Having a tool that allows us to play with lighting, having like practical lighting, natural lighting, diffuse lighting, ambient lighting in a different sort of ways and trying it out in real time, it's completely priceless. We decided to code and develop our own WebGL application that connects the geometry of the building with the database of the unit availability. That is the same type of database that we have for the touchscreen applications. We're experimenting with the Sketchpad in order to be really the tool that allows us to connect one single model into our touchscreen applications and our online applications. We're extremely excited about the future and how we can integrate this not only in the applications that we're doing at the moment, but also in mixed reality applications, virtual reality applications, and virtual production with using nDisplay. Thanks for listening. I hope you enjoyed the presentation and enjoyed the rest of the show.
Fantastic work, Jose. And great to hear from Elad on how virtual worlds are supporting the real estate industry. Next, we're going to bring on the team at Foster & Partners, who have been pushing the limits of real-time technology for over 20 years. Let's hear from Francis and Gamma about a novel approach emerging, the physical world and the virtual, to help stakeholders understand the future in a more immersive setting.
Hi, I'm Francis Aish, Head of Applied Research and Development.
And I'm Gamma Basra, Head of Visualization and Film. We work at Foster & Partners, one of the world's leading architectural, engineering and design studios. We communicate visually using images, films and real-time games engines like Unreal.
We've worked on augmented and virtual reality for many years, developing custom tools that allow our designers to create, analyze and experience their ideas in intuitive yet powerful ways.
Today, we'd like to tell you about some of our latest AR and VR work. The projects we've worked on are still sensitive, so we're going to use a dummy project to illustrate the key concepts.
We use a wide range of tools and media to communicate ideas, as different tools give different experiences. Physical models can give great overviews of a design, but we wanted to explore how best to show the street-scale human experience. We're long-running users of Unreal, with a very good relationship with Ken and the Epic team, so we'd already built a very detailed, high-quality visual model of the new tower and its context in Unreal, and used it for regular VR reviews. We'd also previously conducted VR and AR design reviews using VR backpacks, HoloLenses and iPads. These can be done at one-to-one scale indoors in warehouses, and got very good reaction from clients. We always like challenges, so together with the design team we posed ourselves a harder one. Could we walk the stakeholders around the real site at one-to-one scale, but give them the VR experience of the new building? To help them understand the spatial experience and how the building would fit in within the city as part of the design and planning process. To begin with, we started laser scanning the site and context to align the virtual and real worlds. The site itself is approximately 100 meters square and can be in a dynamic environment with pedestrians walking around and changing lighting. As well as great visuals, Unreal also provided a development platform we used to create our custom software called CloudCom. We also worked closely with HP and Microsoft on the hardware side. We then customized the hardware to enable robust multi-user tracking at this scale. Of course, as with so many projects, COVID got in the way, and for a while we had to continue working in our bedrooms and back gardens. But because of the multi-platform nature of Unreal, we could quickly create an iPad version of our tool, and stakeholders could use that to continue to participate in the process from their back gardens. Once we were allowed back onto site, we continued testing and refining the system, getting feedback from our stakeholders. Critically, this is a multi-user experience, You can see the other participants and speak to them, and point out features of the new building. It's an incredible multi-sensory experience of walking around the plaza, seeing the very powerful virtual visuals, but feeling the real plaza beneath your feet and hearing the sounds of the city around you. Something we found very useful was switching between virtual and real reality to compare and check the present and potential future. And by incorporating screens on the rear of the backpacks, we made the process inclusive to allow larger numbers of stakeholders to participate. Overall, the user reaction has been incredibly positive. We've also developed remote collaboration functionality to allow remote participants to join and contribute to the process. And one future use could be to increase design participation using tablet AR and other low-cost XR devices to allow a broader range of stakeholders to participate. So we think that this has pushed the boundaries of outdoor one-to-one scale VR. This ability to collaborate at any scale and from any location is incredibly powerful. It's giving our clients and designers a way to experience their designs like never before.
The idea that the physical world and the virtual can be brought closer together to drive decision-making is a great approach. And you can see from the hardware that Fosters and partners had to field that we're still in the infancy of using these technologies, but there's no doubt it'll get simpler over time. So thanks Gamma and Francis for giving us a glimpse into the future of XR. Our next presenters are Henry and Caesar from Zaha Hadid. Who hasn't heard of this studio? They are the world's most consistently inventive architectural firms. And you may have read our story on their Honduras configurator, but they're here to reveal details and discuss their results.
We are presenting to you today an overview of platform design and game engine technology at Zaha Hadid Architects to deliver engaging, interactive spatial experiences for clients and consumers.
The Computation and Design Group is a practice-embedded research team focusing on creating computational geometry and building strategic partnerships to bridge industry advances toward project-based applications. We incorporate these advances into workflows at Zaha Hadid Architects to address issues of sustainable development of the built environment.
Shifting design thinking to integrate game technologies and platform development has empowered our capacity to disrupt conventional procurement processes and bring together stakeholders to deliver high-value, locally relevant, resource-effective, supply chain integrated design solutions for residential living.
There are several problems faced in architectural and construction industries for which game technologies are particularly well suited to negotiate. Construction projects take years from conception to occupation, during the course of which markets fluctuate, resulting in misalignments to the consumer base they were originally intended. Similarly, the priorities of key stakeholders, including regulators, developers, operators, and occupiers, in addition to architects and engineers, is often competing, resulting in delays requiring alignment and compromise for success. The Beaboo Residential Configurator is the latest build in a lineage of residential platforms developed at Zaha Hadid Architects with Epic in Unreal Engine, offering investors, occupiers, and developers ways to configure properties to suit individual preferences, offering ability to position units, configure add-ons to the envelope, and customize the interior space layout and fittings as well. Monetizing such features as air and development rights in the process to configure modular building components in real time using a web-based application.
The configurator leverages real-time ray tracing technology to achieve the highest level of visual fidelity for both the interior and exterior of the units. Additionally, pixel streaming enables us to share the configurator experience with clients and with the use of custom frameworks to maintain non-destructive workflows with designers.
Platform design offers clients a universe of feasible variations at their fingertips. For instance, there are over 2,200 ways to configure a custom residence in the Honduras configurator. We have developed and curated a cohesive digital kit of parts that result in vibrant and diverse residential communities. Exteriors and facade kits are created fit for place. The platform approach offers local construction companies, building trades, and local craftspersons to benefit from an infusion of digital technologies into the economy.
Platform design in architecture, engineering, and construction helps to test fit, simulate, and explore scenarios to design market-tested, demand-driven solutions. The configurator can be used socially to curate a community, to accommodate the peculiar spatial needs of family members, invite friends, and connect to like-minded individuals, or to share resources and costs with neighbors.
Health, well-being, and protection of the environment are fundamental to the platform approach, providing consumers with local and renewable materials, such as sustainable, lightweight FSC timber, in structure and cladding options, as well as prefabrication offsite and technology integration, reducing waste and the total carbon footprint of the schemes.
One of the challenges we face has been interface and experience design, developing device actions, storyboarding, heads-up display, and sequence behavior to maintain a seamless, immersive gameplay typically prevalent in gaming environments.
At Zaha Hadid Architects, our workflow is tuned to realize complex geometry as fabrication optimized and manufacture ready. We continue to develop lightweight control mechanisms and retain live geometry as long as possible to empower design, interaction, and exploration. However, game technologies pose distinct real-time optimization criteria for content creation, management, and version control to prepare geometry for the real-time pipeline. We are taking steps towards multiplayer modes of play and distributed gameplay models to capture real-time decisions of human actors in a digital marketplace for real estate bidding, negotiation, and property valuation.
The value of interactivity and occupier engagement in the design process resulted in converted money traditionally left on the table to direct sales of housing units. The immersive environment, coupled with the unparalleled co-authorship of the built environments in Unreal Engine, increased the margin of closed sales while increasing overall unit variability to suit individually and meet investment goals.
Twinmotion's gentle learning curve allowed multiple Rhino users unfamiliar with Twinmotion to learn quickly, deliver stunning imagery, and contribute to content preparation from day one. This empowered the technical and creative aspects of the project to move forward in parallel with a very small project team. With clients and end users distributed globally across both hemispheres, web deployment integration was a priority, which Unreal streamlined. The web-based platform removed potential issues with client-side hardware requirements, technical support, remote connectivity issues, resulting in a simple, seamless, no-nonsense browser design exploration. It's been a pleasure working with Epic to deliver an unparalleled surface model for architectural design, exploration, and delivery. Thank you for your time.
Thanks, Henry and Cesar. It's great seeing more and more examples of companies building sales configurators for real estate. It's officially a thing. And now it's time for Greg from HOK to come back and join his colleague Mark Cici to show us their Twinmotion project taken to the next level in Unreal Engine. They have created a single interactive experience of the Parliament building in Unreal, combining detailed LiDAR scans with design data. And with Joseph Dobos and the team at 3D Repo, they're exploring the creation of a federated model for their daily visualization needs.
Hi, it's Greg again from HOK. CenterBlock is such a complex project, it's important that we give the stakeholders the ability to monitor and view the work as it proceeds. Mark Cici, my colleague, is going to walk you through that process now.
Hi, I'm Mark Cici. I am a principal and the director of design technology at HOK. We currently have about 75 terabytes of reality capture data. That accounts for terrestrial laser scanning, hand scanning, orthographic imagery, and photogrammetry. The reality capture data that we currently have represents the first 3 years of the project's existence. We still have around 7 years to go, which means that 75 terabytes will balloon by the time we get to the end till around 350 to 400 terabytes of data. We've developed an application leveraging Unreal Engine that allows us to concatenate all of the aspects of the reality capture we've done to date. This streams the data in from a variety of sources, including our local data center and Cintu in the cloud. We'll ultimately deliver the application via pixel streaming on cloud. The primary purpose of the pixel streaming application is meant to give context to the entire trajectory of the project. So it allows you to, in effect, trace the entire state of every space in the building throughout its history. That means we can go back to the beginning, before construction, when the building hadn't had any demolition acted upon it. And it means that we can always go back to the very end where we've reinstated the finished materials. We can also investigate anything in between. We can look behind mechanical ductwork. We can see at what state drywall was removed and replaced, and if there's any differential between what the design documents say in regards to where a conduit may be placed or where it actually is in reality. And we can actually track that delta and see over the course of the history of that space where the services are and what the finishes ultimately transition to. Leveraging Unreal Engine and pixel streaming in this way allows us to create a comprehensive and robust versioning system of the geometry and the point cloud scan data throughout the project's entire history. We've been investigating the use of 3D Repo in parallel to create a supplemental versioning system that allows us to trace our BIM-related data and the Revit model specifically throughout its existence so that we can compare that information when upgrades are performed or when major model changes are executed. In addition to this, we've been leveraging the new plugin that's been developed by 3D Repo to be able to stream that content and those differential checks into Unreal Engine. Now I'll hand it over to Joseph to speak a little bit more about that process and what they're doing with Unreal Engine.
Hi, I'm Dr. Joseph Dobosz, the founder and CEO of 3D Repo. With HOK, we've been working on countless innovations over the years, and this project is no exception. We've been instrumental in cloud-based data validation and large-scale geometry processing that would not have been possible otherwise. Using 3D Repo, HOK were able to push their complicated 3D models straight from the authoring tools to the cloud for version control and federation purposes. Since all of the data is available through the APIs, there is no need to recompile and reissue the game anymore, because all of the data is instantly available using Unreal Engine in the editor as well as during runtime. This way, client-facing visualizations can be developed and kept in step with the engineering process without any further delay. HOK were also able to retrieve 3D locations, metadata, and other engineering information directly from the cloud without the need to build their own infrastructure. 3D Repo has been built directly on top of the existing AEC workflows, so Unreal experience can be simply enabled by installing our own plugin. For us, UE5 delivered significant performance improvements, as well as decoupling of the rendering pipeline from the underlying data structures, so that we were able to populate them dynamically on the fly. UE5 was not just about visual fidelity, but more importantly about processing capability and prowess. We are very much looking forward to continued partnership with both HOK and Epic Games.
Now, seeing all this, I think it's a good time for a break so you can reflect on all the magic that you've seen here today before we're heading into our final act, which will look at global scale projects and digital twins. So please stick around, we have a few more announcements to make.
Welcome back, everyone. Before the break, HOK and 3D Repo showed us how real-time technology can be used to federate large models and a glimpse into the great companies like 3D Repo who are incorporating Unreal in their pipelines. Now, as we enter Act 3, we're going to go one step further.
And one step further means connecting the physical and the digital worlds. So in this act, it's all about open worlds and digital twins. You'll see projects that truly expand your horizons, because we'll be exploring global scale projects and connect real-time data to Unreal Engine to create such digital twins. But what exactly is a digital twin, David?
That's a very good question. And if you've looked online recently, digital twins mean a lot of different things to different people. And I've seen the heated forums. So for us, supporting connection in Unreal to your live data sources to empower your digital twins are really key for us. So an example of a digital twin would be, say, a digital model of a city that shows the status of all the traffic lights at any given moment. That would be a good digital twin of a city. So today we'll touch on all aspects of creating a digital twin, from capturing the digital version of the physical asset all the way to a live data feed.
So with Capturing Reality having joined the Epic family earlier this year, the possibilities around capturing the physical world have dramatically increased. And since every digital twin starts with a copy of a physical asset, we're quite confident that we have all you need to get started. Now, I'd like to introduce Elmar Boll to share with you where we are at with Quixel and reality capture.
Hi everyone, my name is Elmar Boll. I'm a product director in the Quixel team. For those of you who don't know Quixel, we've been all about capturing the world and creating digital twins that others can then leverage to create their own worlds. So we've spent the last decade capturing some of the most iconic biomes in the world with our goal to create the Megascan library that's available to you all today and that you can leverage in creating your own worlds. But really for us, the mission is going to be how do we make scanning more broadly available to the world, and how do we enable you to go and scan the world yourself? And with that, we've recently joined forces with Capturing Reality. We're very excited about this because they bring the best 3D photogrammetry technology into the fold, and we're looking forward to actually making that available to all of you. And this will really energize us and enable us to create much easier ways to capture the world and allow anyone to create these real-time 3D experiences to leverage these digital twins of the real world. We just released our latest version of Capturing Reality, which I really encourage you to go out and try. It's got a ton of AEC functions, leveraging drone capture and other types of things. Please go out and try it yourself. You'll be thrilled to use it. But really for us, the next step is how can we let anyone go and capture the world around us to leverage in their 3D experiences. So with that, we're really excited to work with you to get your feedback on this and to continue evolving this tool. And with that, thanks very much. I wish you happy scanning. I look forward to seeing you next time. Bye-bye.
Thank you, Elmar. I mean, there are a lot of steps to the metaverse, but this is certainly one of them where Reality Scan can help our customers capture their world for free. We'll share more information about this and other announcements at the end of the event, so please stay tuned. Now, speaking of worlds, let's also talk about scale. You know, in architecture, projects range from small-scale floor plans all the way up to entire city-scale developments. And if you work with such large-scale assets that cover hundreds and thousands of square kilometers, well, we all know that that can be quite a challenge. But Sebastian Lozé, our industry manager for training and simulation, will now touch on ways to bring such large-scale worlds, along with their plethora of data, into Unreal Engine.
Thank you, and it's very exciting to be here today. Hi, everyone. In the simulation world, one of the first questions we get asked when we introduce what we do at Epic Game is, this is all great, but how large of a world can I handle with Unreal Engine? This question comes from the past, from a time when monolithic application structure was not allowing developers to get more than dozens of square kilometers in a game engine if they wanted to get the right level of visual accuracy. The entire world can be loaded, streamed, or explored in Unreal Engine, and we'd like to introduce you to these large worlds and how to inject them into the applications you create. In addition to the photogrammetry and real-world data capture technology the previous sessions just presented to you, it is important to understand that a plethora of data is already available. This data from the GeoIn community is just waiting for you to be leveraged in your applications. Data captured from the real world can be geographic information system files or 3D environment databases already sitting in a format ready to be just loaded and streamed in UE. In both cases, we worked with seasoned and smart individuals, teams, companies, and global organizations to make sure that we're supporting standard format for large environments the same way we do for 3D models or CAD data. Over the last years, many application creators with expertise in the GIS world added methods to get GIS files as sources in your Unreal Engine projects. To do this, you can simply use the applications of your choice, such as World Machine, Instantera, World Creator, Terraform, Triton 3D Builder, or TerraVista to transform your GIS files into your 3D environment. We also partnered with the Open Geospatial Consortium and the US GeoIn Foundation and others to identify what industry standards and open standards should be supported so that you don't even have to create your dataset, but you can use ones from your ecosystem. Today, the Esri ArcGIS Map SDK, the OGC CDB format, the 3D Tiles format, and the Supermaps format can directly be streamed to Unreal Engine. What we've just described is the last mile to ensure a complete pipeline allowing creators to bring the smallest details of a piece of furniture to the entirety of the Earth into Unreal Engine. Now that we have the content figured out, we need to make sure to develop the right tools inside the engine, like recently in 4.27 when we launched the georeferencing capabilities. This is just the beginning, and more will come with Unreal Engine 5, including world composition and other tools to simplify large world coordinates handling for developers. On top of these developments by Epic, the ecosystem around Unreal is evolving very fast. And today we're introducing you to the work of Blackshark AI. This AI-based digital twin is a geospatial platform offering a 3D semantic map of our planet. Using satellite imagery and various other input sources, Blackshark is extracting information about our environment and reconstructing this information in a 3D way so everyone can virtually interact with and better understand the world around us. Recently, Blackshark has chosen Unreal Engine to be the first game engine to deliver the world's best simulation and visualization capability. Using AI to augment the geodata existing is a disruptive and revolutionizing workflow for all industries, as well as democratizing geospatial data access for everybody. More details about the Blackshark plugin for Unreal Engine will be announced closer to the launch of Blackshark's AI Digital Twin USA. And I recommend that you stay tuned for more on that very topic. As you can see, to the question how big of a world can you ingest into Unreal Engine, the answer today is how much can you dream of? And with humans looking at the stars, aiming to return on the moon or walk on Mars, I would not be surprised to see more planets than Earth simulated in Unreal Engine pretty soon. So with all that, I want to thank you very much, and back to our hosts today.
Thanks, Sebastian. With global data sets from Blackshark, Cesium or Esri and Reality Scan on your phone, it's never been easier to capture your world and explore it with Unreal Engine. Now, for one final time, let's bring back the creative team from HOK to learn how they integrate open worlds and digital twins in their project.
Hi, Greg again. Katie walked you through Twinmotion. Mark and Joseph illustrated our integration between 3D Repo and Unreal. Now we're going to put Centerblock on the campus. Sebastian previously mentioned Esri and Cesium integration. We're going to illustrate how we're using Cesium on the project, and Mark's going to do that for us now.
Cesium presents an exceptional opportunity for architects and designers because it allows us to real-time stream geospatial data directly into our models. This saves us a significant amount of time and resources in having to manually or parametrically automate the development and modeling of the surrounding context. Plus, it has the added benefit of having a community supported and developed around it that enables additional contributors to develop content which would otherwise be difficult to do on a firm-by-firm basis. This represents real, tangible benefits to us on the Centerblock project because it allows us to visualize, along with the client, how the context will appear within the models that we're developing on the project. We're currently investigating and developing a tool that will allow us to tie the real-time sensor data that is being captured by our project partner WSP and their structural geomatics team to a Cesium model that will allow us to correlate both the context and the geospatial-rich reality capture data in one continuous location. There's an exceptional opportunity here to develop a comprehensive digital twin that incorporates all of the data that we've generated from various sources, including our development models, our geospatially referenced point cloud data, and any other related construction 6D, 7D, or 8D BIM-related data. We and the client believe that there's an exceptional opportunity to leverage all of the data that we're collecting on the project and incorporate that into a comprehensive digital twin that will be part of the building's operations and facilities management for years to come.
Thanks, Mark. We've shown you Twinmotion, the many different ways we're using Unreal. We think this integration of external data into real-time technologies like laser scanning, photogrammetry, BIM information is the future and frankly the current way that you must do heritage projects. What we're most excited about is how this will trickle and move into our existing work as we move forward. On behalf of HOK and WSP, I want to thank you for taking the time to let us tell you the story of our once-in-a-lifetime project, Centerblock. Thank you.
Thanks guys, and the amazing team at HOK for your videos over the 3 acts, showing how a company can start with Twinmotion, but then evolve your project into Unreal and tackle any scale using our tools and ecosystem. Now, just like we saw in the HOK example, the crucial part of a digital twin is that connection to the real world. Presenting live, real-time data from IoT sensors and other sources in that 3D context can accelerate decision-making and anticipate problems. You see, the world we live in is growing ever more complex, and we'll need methods of presenting information in an intuitive manner. There's going to be a million different forms of digital twins, from helping us make better decisions in the design and operation of a building to public engagement within a city. So let's check in with some companies who are working to connect Unreal Engine to the real world. First, we'll hear from Shi Yanji and his team at Vouse. They'll show their efforts to build a digital twin of Changi Airport in Singapore, which in 2019 had almost 190,000 people per day using the airport. So understanding what's going on at any moment can be quite crucial.
Hi, I'm Yanji from Vouse. We are a design agency based in Singapore. Vouse is an assemblage of architects, programmers, and game designers. We use game engine in the architecture and built environment sector on a wide range of projects ranging from residential to commercial and even to heritage. Our projects are often tailored specifically to the needs of the client, and we deliver from the conceptual stage all the way to development of the software as well as maintenance of the project after it's completed. Today I'm very happy to share with you our project with Changi Airport Group, the Changi Airport Digital Twin. Vouse has always been a partner of Changi Airport Group since 2017. And we developed a digital twin of Changi Airport over the past 2 years together with Mr. Ao Ching Wen and his colleagues from T5 Planning. The digital twin is around 1,300 hectares, and that is roughly the size of 3,200 football fields. Our approach to digital twin is to build a data integrated model. We stream in live operational data into the 3D model, and we use that as a base to develop applications for different end users of the airport. The reason that we chose Unreal Engine is because of its ability to provide real-time graphics, but at the same time, we can integrate with back-end databases, and this allows us to scale with the size of the project. Throughout the 2-year period, we deployed to different platforms and applications from the same project file. The base model was built based on CAD and BIM information. The 3D models are constructed modularly and assembled in Unreal Engine to take advantage of the many optimization tools often used for open-world games. This includes instancing as well as the foliage tools. This is important because on a project of this scale, your performance is key. Using georeferencing, we align the model with real geo coordinates that allows for integration with sensors and data. With Blueprints, we build integrations with the Changi backend databases that streams in live data and projects them onto the model in real time. To talk a bit more about the technical details, let me invite the next speaker, Poon Hei, who is our senior developer of Vouse.
Hi, I'm Poon Hei, a senior software developer at Vouse, talking about our application which uses aircraft transponder data to visualize the position and movement around a digital scale model of Changi Airport in Unreal Engine 4. The application can display plane position and additional information in real time, relayed from a server in the airport. It also allows users to play back historical simulation records transmitted from the server itself or from records stored in a local database. Going forward, our future plan is to integrate as much information as possible into the application to serve as a central hub of information for monitoring purposes such as arrival and departure times at each gate, human traffic counters, temperature and humidity sensors, and so on.
Thank you, Poon Hei. That was an example of deploying the digital twin on a macro scale. On a more micro scale, we investigated the road and traffic infrastructure from the angle of the actual user by deploying the digital twin onto a driving rig. We showed that the detail level can be achieved with ground level signage and markings. With this, end users such as technical staff and operators of the airport who may not be familiar with architectural drawings can be engaged to test out the digital twin. This opens up opportunities with the complex tools that Unreal provides to build scenario training and design validation applications. This is especially important in today's world where digitization and remote training become increasingly important. The digital twin is currently deployed internally in Changi Airport. It is meant to be a live model, which is consistently updated with new content and features. This project serves as a foundation for Changi Airport Group to continue exploring digital transformation in the domain of airport planning, simulation, and operations. Thank you for listening to my presentation. I wish you a pleasant evening and please enjoy the rest of the events. Thank you.
Thanks, Yanji. Great example of how Unreal Engine can tie together many different data feeds into one easily understood context. The team at Vouse has showed us how owner-operators can use digital twins to manage their complex assets, but what about the public? Could they benefit from a digital twin? Tim Johnson from Buildmedia has been working on such a project with the Wellington City Council in New Zealand. Let's go see where it's at.
Hi, my name is Tim Johnson. I am the Technical Director here at Buildmedia. Unfortunately, due to New Zealand's COVID lockdown and social distancing requirements, we're unable to bring our full presentation. However, the Buildmedia team is still very keen to share the Wellington Digital Twin and how it was created. Buildmedia is a visualization and experiential studio creating meaningful digital experiences. The team is a mix of specialists ranging from gaming, programming, animation, visualization, GIS, and architecture. We love pushing the boundaries in everything we do using Unreal Engine. Unreal Engine has allowed us to explore new industries and capabilities we never would have imagined only a few years ago, and the Wellington Digital Twin is one such project. Buildmedia has visualised many large-scale infrastructural projects across New Zealand and Australia, and spent years creating accurate 3D visualizations, placing these in context to help stakeholders and the public understand the scope and impact of a project. With the Wellington Digital Twin, we wanted to create a dynamic, real-time model that presents information in a non-linear and engaging way, bringing together our visualization capabilities with sensor, geospatial, building, infrastructure, and online data from across government and non-government organizations. The aim is to help make better multi-agency decisions, understand complex issues like climate change and economic development, and most importantly, as with all our visualization work, better engage with the communities and stakeholders. We've been developing the Wellington model over the last few years, using it to create a number of animations, visual simulations, which are accurate photomontages, and marketing imagery. With everything we have learned with UE4, we decided to take the leap and bring the entire model across into Engine and push what could be possible.
Hi, I'm Vincent, one of the lead CG artists at Buildmedia. I'll be walking you through how it was created and how you can get started on your own digital twin. When building any kind of digital twin, ask yourself, what are we trying to achieve? This helps you define the scope of the project and where to direct your efforts. For Wellington City, accuracy and the visual appeal was our main focus. Wellington was created using a number of data sets from multiple agencies. The availability of good spatial data is one of the key factors for a successful twin of a city. Work with your local geodetic system so that surveyors, engineers, and architects can all be coordinated to the same reference point. We started with a small area and continued to expand the model outward to keep on top of optimization. We were surprised every day as we continued development just how much you can throw at an Unreal Engine. Starting with the terrain, we used publicly available contour data from Land Information New Zealand. We generated height maps and exported terrain tiles as static meshes from 3ds Max. In the material, a world position offset function creates the Earth's curvature. Projects were modeled and animated in 3ds Max and imported through individual datasmith files, with materials automatically assigned in Unreal Engine through data prep. For the buildings, a detailed photogrammetry model of the CBD was supplied by Wellington City Council, 18,000 buildings with unique 3D models and textures. Unreal Engine has inbuilt optimization tools that were key to manage draw calls and getting a stable frame rate. Using blueprints and shapefiles, we accurately placed trees, streetlights, cars, boats, and even wind turbines. And finally, my favorite part of the project, we let Unreal Engine's amazing volumetric cloud and atmospheric system bring the scene to life.
The Wellington Twin is connected to IoT sensors located across the city, bringing the Unreal model to life. We capture and record traffic volume, cyclist movements in and out of the city, pollution levels, pedestrians, temperature, weather, and more. We access this data using REST API, a mixture of JSON, XML, and HTTP requests depending on the data source. This is very straightforward using easy-to-find UE4 plugins on the marketplace. It is still early days connecting to the Wellington Digital Twin infrastructure, and we're excited to explore this further. The Wellington Twin is also used to visualize a number of projects around the city. These projects have been included in the model for public consultations and stakeholder meetings. From our experience, the consultation phase is critical for any major project. Having all the information in one place makes it more efficient and effective to engage with the industry and public stakeholders. It can also provide a history of proposals and feedback. Every model, every decision can remain within the interface. This then demonstrates to the public that they are valued and engaged throughout the whole consultation process.
Kia ora, my name's Sean Ordain and I'm a City Innovation Lead at Wellington City Council working on our Digital Twin project. Here in Wellington, we've been investing in a digital twin because it helps us understand and communicate the future of our cities and the complexity of what makes it work. What we love about Unreal Engine is its ability to take disparate data feeds and put them into a universal experience which we can use to help make that future real for people. Our aim is to be an informed democracy, and so that ability to universally fuse together that future of the city is everything to us.
Pixel streaming will enable us to share the digital twin throughout the council and potentially in the future to the public. Streaming the digital twin from the cloud means more people are able to access and utilize the twin for presentations on any device. Messaging is then consistent across all departments. We want the Wellington Digital Twin to enhance public, agency and stakeholder collaboration, encourage open data and stimulate the co-designing of Wellington for the benefit of future generations. Buildmedia is looking forward to the continued development of the Wellington Digital Twin in Unreal Engine and hope this will be a great asset to the city. Thank you.
Thanks, Tim and the team at Buildmedia for giving us a glimpse of how anyone might use a digital twin to either learn more about their city or simply make better decisions.
And finally, before we go, we want to make it easier for any of you to build a digital twin. Earlier on, we heard Pierre Felix mention some of the efforts we're making around Unreal Engine 5 to support native methods of using various protocols. But we also have something that you can play with now.
Because earlier this year, we awarded a mega grant to WSP, a global engineering firm, to bridge the gap between Microsoft Azure's digital twin platform and Unreal Engine.
A team at WSP's Swedish office, together with Microsoft, have created an Unreal Engine plugin and sample project to help people get started with digital twins. The resource includes an application showing a floor plan of a building, a scripted installation of all the necessary Azure IoT and digital twin components, and even an IoT device simulator.
And this sample project shows different ways of visualizing real-time data, from using our Niagara particle system to show airflow and temperature, to utilizing our lighting methods to show when lights are on or off. We even use our animation control rig to simulate people entering and exiting a room. It will also show you how to connect to Azure's digital twin suite of tools, such as their time series insights, to get historical context.
We've documented all of this so that you'll know exactly how to leverage the resources to build your own digital twins. And all of this is open source and free and available on the Unreal Engine Marketplace today. A massive thank you to WSP for their contribution to the digital twin community.
And that's us. In the last 90 minutes, we have shown you how you can tell your stories using Twinmotion and then create unlimited worlds in Unreal Engine. We have shown you how our customers are experimenting with these transformational technologies and what they have learned so far.
We've also shown you where these technologies might take you if you master them and deploy them on your most complex problems. This is a journey, and we're all just starting to unravel what's possible. We're at the earliest stages of exploring how these immersive technologies will benefit people and lead to new efficiencies.
Now, not everything will be a success, but we'll learn from the failures and use them to power a better future. one where people take a more central role in the design of their spaces and will have better access and insights on the data driving the world around them.
So what's the next step? Spend a lunch break with the free trial of Twinmotion and see what stories you can tell. It might just change your life like it did for Poel. See you later.
Bye-bye.
Bye, everyone.